Hello, class. Continuing stats lecture on section 3.3. This recorded lecture will talk about calculation of percentiles. So basically, percentiles are a way to split the data up into more finer pockets of data, in the sense that we talked about the 25th percentile, right? The 50th percentile and the 75th percentile, which was quartile 1, quartile 2, or the median, and then quartile 3, which was 75%. And we could break those down even more granular, right? And we could find the 10th percentile, the 15th percentile, the 99th percentile. And so what that means is that the percentage of data is below and above will correspond when you add those all up. You always get 100%. And so again, we have a couple formulas to introduce. Again, criticizing the book a little bit, but I like the way they do this as well. And so they use this same idea of calculation of this position, or what I call index sometimes, of L. And so when you want a procedure to compute the percentile of any data point, first thing you do is put it from increasing to decreasing order, and then figure out your index, number 1 all the way through number 13 in the examples that we've been using. And now we want to calculate the L value using the percentile. And you can see it's the percentile divided by 100, which converts it to a decimal. And then you multiply it by n. Same thing happens. If it's a whole number, you take that number and the next one, index, and you add them together and divide by 2. And that will give you the percentile average of those two. If it's not a whole number, you round up again. So again, just like the same calculations we did on the quartiles, except we're expanding it now. So instead of putting 0.25 in there, we could put 0.1, 0.99, et cetera, et cetera. So what I'd like to do is use that same data and go through an example or two with regards to calculation. So again, this would be P over 100 times N, which is the total number of samples we have. So say like you want to calculate the 15th percentile. So the way that you would do it is L equals 15 divided by 100. And we had, in our data set, we had 13 as our 13 home prices that we went through when we did the quartiles. So we're going to use the same data set here. So when you do this calculation, it would be 15, 13 times, and then you divide by 100. And you could see that the 15th percentile is 1.95. So that's real close to 2. So you round up to the second position or second index. And then we'll just go back to the data set. And again, here was our data set that we used before. So index number 2. So out of this data set, that would be the second position, right? Second index. And that would be our 15th percentile. So let's do one more. Say like we want the 60th percentile. Just picking numbers. And so that would be L equals 60 divided by 100 times 13. And 13 is nice because it'd be hard to get an integer. So, and then 13 times gives us 7.8. So we round up to the 8th position, right? Or the 8th index as I use my spreadsheet. So we go up to screen 2. And what is the 8th position? It's right here. And you should think that that would be. So I'll highlight that in yellow. So that would be our 60th percentile would be $529,000 for that. So that's how you, given a percentile, what data point, what value of the data point is that percentile? Well, what we're going to do now is show you the other calculation. And what do we mean by the other calculation? Well, the other calculation is given a data point, what percentile that is. And so here you're kind of flip-flopping the calculation. So when you're given a percentile, you want to find the data point. But if you're given a data point with regard to that, you want to know what percentile that data point is with the overall data set that you have. And so that is this calculation. It's a little bit weirder. And so I'll walk through a couple examples, but the way it works is that you're going to calculate a percentage. That's why we're multiplying by 100 here in the percentile. So the number of values less than X. And so what that means is that if you're looking for the percentile for, say, index 5, you want everything less than that. So that would be 4, 3, 2, 1. So there would be 4 numbers less than that. And then you add a half to it, and then you divide by n, which is the total number of data points. And then you round the result to the nearest whole number. This is the percentile corresponding to the value. This is what I don't agree with in statistics, is for some reason they don't like percentiles that have decimal points in it. I'll tell you, as an engineer, when we were doing these percentile calculations, we always left the decimal point. But that's okay. So let's take a look at our data. And let's no fill these so we clean it up a little bit. And so now let's calculate the percentile of item number 3 here, which would be 230,500. And so that's position number 3. So here's how we do this calculation. So let me pull up the whiteboard here and show you the calculation. So this is position number 3, right? Or index number 3. So how many are less than 3? Well, that would be just 2. So the first number we plug in is 2. So, and then we add it to a half, and we divide by n, which is 13. And then you multiply it by 100 to give us a percentile. So if we do that, you get 2.5, 13 divide, and you multiply it by 100, and you get 19.23. And so the way that the stats people like to do it is you round this up to the 20th percentile. So let me go back to the formula in the spreadsheet and to show you where those numbers came from. So here is the number less than X. So that would be 2, right? Because we were doing position 3. We added a half to it. That was the half right here. And then we divided by the number of values in the data set. That's typically called n. I don't know why they don't use n here. And so that would be 13. And then at the end, we multiply it by 100. We ended up with 19 and some change, right? And so we go to the round the results to the nearest whole number. oops, I rounded wrong. So results rounded to the nearest whole number. And so it doesn't say round up, it says round. Sorry about that. So that's not 20%. Teachers make mistakes too. 2, 3, you would round down to the 19th percentile. So let's do one more. So if we go back to the data, let me pull the data up. Let's do one more. And so let's find the second to the last one. So let's do index number 12, or the 12th position, 1,095,000 housing price. So if we do that one, let's go back to the whiteboard. And so this would be position 12. And so we would be 11, which is 1 less than 12, plus 0.5 divided by 13 times 100. So when you do this calculation, it's 11.5 plus divided by 13 and times 100. I ended up with 88.46. So let me round this one correctly. Since 4 is less than 5, we don't round up, we keep that. So that would be the 88th percentile. So to walk through all these calculations, a little tedious, but if you follow the process, it works actually quite well. And so that ends this recorded lecture talking about calculation of percentiles in a data set. And so the last one we'll talk about this 5-number set and generating a box and whisker plot.